In this JavaScript project, we will be building a countdown timer based on the JavaScript date objects. So the way that it works is that we set the date when we want the timer to stop. The timer then starts counting down, and when it reaches the set date, then it triggers an event. This is going to be a simple project, but you will learn things like how to use the JavaScript date object, what are setInterval and clearInterval methods, what is CSS attribute function and how to use it, how to deal with the CSS animation using keyframes, how to use and display Fontawesome Icons, and a lot more. But before we start, this project has some prerequisites. You should know basic HTML, CSS, and JavaScript. But if you're just new to programming, you are also welcome too. It will give you a bird's eye view of the processes in creating an application. So once you're ready, we'll start in 3, 2, 1. Okay, for this project, I'll be using Visual Studio Code. And of course, you can use any text editor that you are familiar with. And for the web browser, I'll be using Google Chrome. You can download the starter files for this project with the link provided at the description part of this video. Or we can create them together. Alright, let's create a folder in our desktop and name it Timer. Right-click on the folder and open it with Visual Studio Code. Inside VS Code, create 3 new files under the Timer project. First, the HTML file, and let's call it timer.html. And then the CSS file, call it timer.css. And finally, the JavaScript file, and let's call it timer.js. Okay, in timer.html file, let's create the HTML boilerplate using emmet. And we can do this by typing an exclamation mark followed by the tab key. Now let's change the title to Countdown Timer. Save it. And then open the file with Live Server by right-clicking on an empty space and then click Open with Live Server. Now, if you don't see this option, you have to install the Live Server extension. And to do that, go to Extensions and search for Live Server. And then click Install. Now let's run the file and it will open with whatever the default web browser that you have. And in my case, it's Chrome. Now you don't have to use Live Server. You can simply go to the folder that we've created earlier and double-click timer.html. However, you have to reload the page every time you make changes to any of the files inside this folder. Now, back to the HTML file. Let's link our CSS file to HTML using the link tag. Save it and verify that the file is actually linked by going to the CSS file and change the background color to red. And then click Save. Okay, it works. Let's delete it and save. Now, let's link the JavaScript file using the script source attribute. Save it, and then verify. Go to the JS file, display an alert, and save it. Alright, everything works. Now, instead of clicking Save every time you make changes to any of our files, let's just set VS Code to automatically save our files every time you make changes by going to the File menu and then select Auto Save. Okay, now go to timer.css and we will import 2 things. First, the Google font and then the Fontawesome icon. Let's head over to fonts.google.com and search for Orbitron, the font that we will use. Select it, select this style, select import, and then copy the link and paste it in our CSS file. Now let's verify if the link works by going to the HTML file and then displaying an H1 element with the default font of Times New Roman. Now let's change the font family by copying the CSS rule from the Google page and paste it in timer.css inside the body element. Now the font changed to Arbitron, so the link works. And for Fontawesome, let's head over to cdnjs.com and search for Fontawesome. Copy URL and then paste it in timer.css inside a pair of code. Now, to display a Fontawesome icon, we use the I element. We need 3 classes to define a Fontawesome icon. For example, to display a bell icon, first we need to define the type of icon, and Fontawesome has 5 types of icons: solid, regular, light, duotone, and bronze. So if you want to display a solid icon, then the type class name will be FAS. FA stands for Fontawesome and S stands for solid. And for regular icons, it's FAR. For light icons, it's FAL. For duotone, it's FAD. And for bronze, it's FAB. Second, we need to define the name of the icon, which is bell, BELL. Now, for the name class, it has to have a prefix of FA dash, followed by the name of the icon. So for the bell icon, the class name will be FA-bell. And finally, we need to define the size of the icon. The icon size ranges from 1x to 10x. Again, for the class name, it has the prefix of FA dash. So for 4 times the icon size, the class name will be FA-4x. And so a solid bell icon is displayed in our page. So we know it works. But how do you know the name of the icon? I hear you ask. So let's head over to Fontawesome website. It has 2 versions, the free version and the pro version. For the pro version, you have to pay $99 per year, but you have access to more than 7,000 icons versus 1,600 plus icons. For the free version, of course, you don't have to pay, and you don't even have to be a member in order to use those free icons. Alright, so let's choose the free icons. Click on it. And right now, we are looking at free icons that are currently available, and there are 1,608 icons that we can use for free. And if you look at the left side bar here, you can see the 5 types of icons that we talked about earlier: solid, regular, light, duotone, and bronze. So if you want to display a brand icon, let's say an Amazon logo, right here, and its name is Amazon, so the type class name will be FAB for brands. And then the name class will be FA-Amazon. And for the size, let's just use FA-4x. And here you go. We have the Amazon brand. And you can change its color the same way as a regular font. For example, if you wanted to change its color to red, go to timer.css and change its color property to red. Okay? Alright, so here's the user interface of our counter while it counts down. It has an h1 element and a div element that contains 6 div elements inside it. 1, 2, 3, 4, 5, and 6. Now, these labels here at the bottom are placed using the CSS after pseudo element. Now, if you're not familiar with it, after pseudo element can be used to insert some content after the content of an element. So for example, this element right here was inserted after this div element and its content. So the position of this element is relative to where this div is located. So we set the position of this to absolute and then the position of this div to relative, as we shall see later on. Now, all of these elements inside this orange div are set programmatically, and we will use the inner HTML property of this div element to set its value. Okay, now the reason why these 6 divs here are contained inside this orange div is because we will use flexbox to position them. And as you know, in order to use flexbox, the element that you want to position must be inside a container. We will also use flexbox to position the content of each div here. Now, if the time count reaches 0, then the user interface changes to this. We simply change the inner HTML value of this div to Merry Christmas, and also the value of this h1 element into a Fontawesome icon. And then we will apply CSS animation using keyframes to make this icon and these text blink or flash every second. Alright, now let's get familiar with the containers or the div elements and their class names that we will use for this project before we actually do the HTML markup. For the main container, this yellow border here, its class name is main-container. This will basically hold all the components that we will use so that we can easily center them. Now, this red border here has a class name of timer-container. It will hold 2 components, this h1 element and this div element here with orange border and with a class name of timer. This will eventually hold these 6 div elements that we talked about here. Alright, let's do what I call blocking as opposed to wireframing. It's kind of like the bird's eye view of our user interface, how we generally set it up. Okay, first let's set the web page background color to black, and then set up the main container by setting its width to 80% of the web page width, and then set its height to 100% of the viewport height. Okay, now we center it using margin 0 auto. Next, we set up the red container with the same width as the yellow container, which is its parent, and place it 15% from the top relative to the yellow container. And then we place the h1 element inside the red container, followed by the orange container. Now, to provide space between these 2 elements, we set the div's margin bottom property to 80 pixels. And then finally, we programmatically set the actual counter inside the orange container. And that's all there is to it for the UI. It's pretty simple. So we expect our HTML markup to be short and simple too. Just a bunch of divs. Alright, so let's go back to our HTML file and let's finally do the markup. Alright, so I'll display these diagrams here as a reference while we are creating the UI. Now, first let's delete these lines since we don't need them. Now, let's create the main container, this yellow div here. It has a class name of main-container. This will serve as a wrapper div that will be used for positioning the entire elements in our UI around the page. And inside this main div, we have the red container with a class name of timer-container. This div holds 2 elements, an h1 element with a value of Christmas countdown, and then this orange container here with a class name of timer. And that is it. Our HTML markup is done. And here's the overview of what we will do. First, we will apply a CSS reset since some browsers have default margins and paddings already applied, such as this spacing here, and we want to get rid of these default settings. Next, we will style the body elements such as the background color, the font family, and its color. We will style the main container by defining its width and its height and place it in the center. For the timer-container class, we will define its width and make its contents align in the center. We'll style the h1 element's font size and transform it to uppercase. We will apply flexbox to the timer class to position these 6 div elements. And to apply styling to each div element and its contents, we will use this selection. Remember the after pseudo elements that I talked about? This is the part where we define it and apply style to these labels. This column class will style the 2 columns that we have here, and finally we create animation with keyframes and with this class which we will call flash. Okay? Alright, I already finished typing the entire style for this project, and I just turned them off by putting a comment on each line like this. Now, I will turn them on one at a time while explaining, and I want you to pay attention to the browser and see what happens if I turn on or uncomment a line to get a feel for what a certain CSS property does. Okay? Finally, let's start styling. Let's perform a CSS reset to reduce browser inconsistencies in things like default margin, padding, and box sizing. If you notice here, there are margins already assigned by the browser. Top margin here and left margin here. So let's get rid of them by setting the margin property equal to 0. Now the spacing is gone. Let's also set padding to 0. And then finally, let's set box sizing property to border box. And this allows us to include the padding and border in an element's total width and height. Alright, let's move on to the body element by setting the background color property to this color, #171717. Okay, we have the font family already set earlier to Arbitron, and let's just change its color to #DDD. Now, let's style the main container. To make this container visible, let's temporarily set its border to 1 pixel, solid, and yellow. We will delete this later on, so let's put a comment here, delete after, so that we can easily find it later. Okay, let's make its width 80% of its parent's width and set its height to 100% of the viewport height. And let's center it using margin 0 auto, meaning top and bottom margins equal to 0, and left and right margins equal to auto. Alright, now let's apply styles to timer-container. Again, temporarily assign a border of 1 pixel, solid, and red, and then put a comment delete after. Let's set its width to 100% of the width of the yellow container. Let's center its contents using text align center. And then we'll make its top position 15% relative to the yellow container. So in this case, let's set the yellow container's position to relative and set the position of the red container to absolute, and then set its top property to 15%. Alright, now let's style the h1 element. Make its font size 50 pixels, font weight 400, make its text uppercase using the text transform property, and set its margin bottom to 80 pixels so that we have a separation between the h1 element and this orange container here. Alright, now let's move on to the orange container with the class name of timer. Let's set its border to 1 pixel, solid, and orange, and set its padding tab to 60 pixels. Okay, now remember I mentioned before that the contents of this orange div will be set programmatically, so go to timer.js. Alright, now let's define a constant called timer and set it equal to document.querySelector and select the timer class since we will be working on this container, this orange div here. Now, let's set the inner HTML value of this orange div. Timer.html equals some template literals or template strings using backticks, which allows embedded expressions or substitutions. Now, there are 6 inner divs inside the timer div. 1, 2, 3, 4, 5, and 6. So let's create them. Now, let's assign a temporary content inside each div, 01, 02, a colon, 03, a colon, and then 04. Now, we want these divs to be positioned horizontally like this, instead of vertically. And here's where the CSS flex box comes in. Go back to timer.css, and under the timer class, set the display property to flex. And by default, the flex direction is equal to row. Now, if you set it to column, we are just back to vertical position. Let's bring it back to row. Now, you don't have to define the flex direction equals row since it's the default setting. But let's just leave it there to remind us. Okay, let's bring these divs to the center by setting the justify content property of this orange div to center. Now, let's style each div here. Let's make the font size bigger, about 50 pixels, and make the font weight 400. Let's set the border to 1 pixel solid and gray. Set the background color using RGBA 99, 93, 93, and transparency of 0.9. Let's set its width and its height to 120 pixels. Now, again, using Flexbox, we can easily center each content inside its parent div. So set the display property to flex. Let's align each content vertically using align items equal to center. And then align them horizontally using justify content center. Alright, now let's provide spacing around each div by setting the margin property to 0 pixel top, 20 pixels right, 100 pixels bottom, and 20 pixels left. Now, let's style these 2 columns here. So, create a class named column inside the timer class. And then go to timer.js and assign the column class to each div element that contains a column. Now, let's go back to timer.css and apply style to the column class. Let's set its width to 10 pixels, set its margin left to 0, and also margin right equal to 0 as well. Let's remove its background color by setting it equal to the body element's background color, which is #171717, and then remove the border by setting its border property to none. Now, let's work on these after pseudo elements: day, hour, minute, and second. Alright, remember I mentioned earlier that the after pseudo element can be used to insert some content after an element. So let's apply this concept to each div element here. Let's select timer div followed by the after pseudo element. Now let's say we want to display the letter A after each div here. And to do this, we simply set the content property of the after pseudo element of these divs to the letter A, like so. And as you see, a letter A appears after each div's content. For instance, 01 followed by the letter A, 02 followed by A, and so on. Now, let's make the font size smaller by setting them equal to 18 pixels. And then let's position them below and relative to their corresponding div element. So set the position of each div to relative, and set the position of the letter A to absolute. And then finally set the bottom property to minus 60 pixels. Alright, now we have a content after each div element at the right location. But this is not exactly what we want. What we want is a unique content after each div, and we don't want any content after those divs that contain a colon. Well, an easy way to deal with this is to use the attribute CSS function, which is the attr function, and assign it to the content property here like so. Instead of the letter A, this function returns the value of an attribute of an element, and in this case, the elements are these divs here. For instance, if we want to display the word day after this div element here, we assign a custom data attribute for this specific div and set it equal to the word day. And this function will retrieve that value as long as the same attribute name is placed inside the parenthesis here. And since the value of this function is assigned to the content property, then the word day will be displayed. Alright, let's just do it. First, let's assign a custom data attribute, and let's call it data-label. Let's copy this attribute name and then go to timer.js and paste it on the first div element, and then set it equal to the word day. And there you go. We have the word day displayed after the first div. Alright, let's do the rest. For the second div, set it equal to hour. Now, we don't want anything displayed after the colons, so let's do the fourth div and set it equal to minute. Let's skip the fifth div since it's a colon. And finally, for the last div, set it equal to second. Alright, now we are almost done with the UI. Let's remove these temporary borders that we set up earlier, remember? Go back to timer.css and remove the border for the yellow and the red containers. And finally, since our timer simulates an LCD digital timer, it should be luminous in the dark. So let's apply box shadow to each div here, except for the divs that contain a colon. So go to the selector timer div and set the box shadow property to 0 horizontal offset, 0 vertical offset, blur radius of 20 pixels, and RGBA of 202, 168, 168, and a transparency of 0.5. And then remove the box shadow of these columns by setting it to none. Alright, finally, our user interface is done. Now, in order for a timer to really come alive and to work as you would expect it to, it needs more JavaScript code. So let's head back to timer.js and talk about the date object. Alright, it's now time for JavaScript coding. But how do we go about coding our project? Where do we even start? Alright, let's take a look at our finished project and see what are the things that it requires. This is what our project looks like when it loads. Our goal is to display the remaining time of an event that we set in terms of days, hours, minutes, and seconds. And once the remaining time reaches 0, then we trigger that event. And in our case, we display a message. Now, the program is mainly about time, right? And basically, it requires 3 things. First, the current time. And this time period is dynamic, meaning it changes every time the clock ticks. Second, the future time. We set this time period, and it's static, meaning it doesn't change over time. And third, deltaT, which is the time interval or the time difference between these two time periods. Alright, since we are dealing with time, we need to establish a time reference where we can measure from. So let's create a time axis with a unit of hour. It starts at 0 with an interval of 100 like so. Now, let's measure the current time from t equals 0 and label it as T sub C. And from this example, T sub C is equal to 400 hours. Also, let's measure the future time from T equals 0 and give it a label of T sub F, and it's equal to 900 hours. Now that we have these measurements, we can calculate delta T. Delta T is equal to TF minus TC, which is 900 hours minus 400 hours equals 500 hours. And this is the number of hours that will elapse before the current time overlaps the future time. Now, once we obtain delta T, we can convert it to number of days. And whatever the remainder will be turned into hours. And the hours remainder will be turned into minutes. And the minutes remainder will be turned into seconds. Alright, let's have an example using a delta T that includes decimal numbers. Let's say we have a delta T of 726.123 hours. Remember, delta T is the remaining time. Now, let me draw part of our user interface here as a visual reference like so. The first thing that we will do is convert delta T into number of days. So, 726.123 hours multiplied by a conversion factor, and hours will be in the denominator so that we can cancel the hours unit, and we know that 1 day is equal to 24 hours. So 726.123 divided by 24 equals 30.255125 days. Now, we display the whole number part, which is 30 days. And the decimal part here will be converted into hours. So 0.255125 days times a conversion factor. We want to cancel day, so we place day in the denominator and hours in the numerator. We know that 1 day is equal to 24 hours. And then we cancel day. So 0.255125 times 24 equals 6.123 hours. We then display 6 hours like so, and then we convert the decimal part into minutes. So 0.123 hours times 60 minutes divided by 1 hour, since 1 hour is equal to 60 minutes. And it's equal to 7.38 minutes. Again, we display this 7 minutes and then convert 0.38 minutes into seconds. So 0.38 minutes times 60 seconds divided by 1 minute, and that will be 22.8 seconds. And then finally, we display 22 seconds. And that's how we will approach our program. Calculate delta T, then just use the conversion process. Okay? Now, how do we implement all of these using JavaScript? How can our code obtain the current time, and how can it set the future time? Well, that's where the JavaScript date objects become so useful. Let's head over to MDN Web Documents website and search for the date objects. Or you can just Google it, type in MDN JavaScript date object, and it will bring you to this page. According to this document, the JavaScript date objects represent a single moment in time in a platform-independent format. They contain a number that represents milliseconds that have elapsed since midnight on January 1st of 1970. So that means from our diagram here, instead of hour, we use millisecond. And the 0 reference here represents January 1st of 1970. That means the current time and the future time are measured from this date. So we expect the numbers here to be very, very large since the time unit is in milliseconds. Okay? Now let's go back to our JS file. Right-click on the browser and click Inspect to access the console. Then select Console. So our goal is to get the current time, TC, set the future time, TF, and obtain the time interval, deltaT, using the date object. To get the current time, all you have to do is instantiate or create a date object using the keyword new. So let's just do that. Let's define a constant, call it TC, and set it equal to new date. Let's print it to the console, console.log, using template literals with backticks. And if we inspect the output, it says TC equals Thursday, November 18, 2021 to AM 13 minutes and 9 seconds. So by creating a date object here, we are able to tap into our computer's system clock to 13 AM, Thursday, November 18, 2021. They matched. Note that this is just one instance of time. We only ran this line of code once. That's why these remain at 9 seconds while my computer's clock continues to tick. And we will deal with this later on how we can dynamically get the current time. Now, to get the millisecond equivalent here, all we have to do is subtract 0 from the new date object. And there you go. We have the number of milliseconds that have elapsed since January 1st of 1970 up to the point when I ran this code. And that will be 1,637,230,626,691 milliseconds. Let's quickly verify this number. Using Google, let's convert this large number into number of days. Copy this number and on the search bar, paste the number, then add millisecond to day. And we have 18,949 days. Let's use approximation to justify this number, at least the 18,000 part. So year 2021 minus year 1970 equals 51 years. And since 1 year is equal to 365 days, so 51 times 365 days equals 18,000 days. Okay, they matched. Now, let's set up the future time. And in our case, it will be on December 25th, 2021, just right after Christmas Eve. So const tf equals new date. And then we input some parameters for year 2021. And for month, it uses 0 index, meaning 0 for January, 1 for February, 2 for March, and so on. So for December, it's 11. For day, it's 25th, then 00 hour, 00 minute, and 00 second. Let's print this using console.log. So if we check the output, TF is equal to Saturday, December 25th, 2021. And if we subtract 0 from this new date, we get TF equals the future time in milliseconds from January 1st of 1970. Now, we can easily obtain deltaT. So const deltaT equals TF minus TC. And let's print it. We now have the value of deltaT in milliseconds. Again, this set of values is just for one instance of time only. If we reload our browser, then TC will change so as deltaT. Now, since we indirectly need the values of TC and TF in milliseconds, we can just directly subtract TC from TF without referencing from 0, just like so. And it will still give us deltaT in milliseconds. And if we continue to reload the page, the value of deltaT changes like before. Now, can we calculate the equivalent days of this number and then turn the remainders into hours, minutes, and seconds? Yes, we can. We've done it earlier. But this time, deltaT is in milliseconds, not in hours. So let's calculate it. Okay, deltaT is equal to 3,188,468,173 milliseconds. We want to convert from milliseconds to number of days. So we need to multiply this number by a conversion factor that involves millisecond. And since we want to cancel this unit, we place it in the denominator. We know that 1 second is equal to 1,000 milliseconds. And then we cancel milliseconds. Alright, let's get rid of the second unit by multiplying it by 1 minute over 60 seconds, then canceling seconds. Let's cancel minute by multiplying it by 1 hour over 60 minutes. And then to cancel hour, multiply it by 1 day over 24 hours. Then we are left with days, and that's what we need. And using a calculator, the answer without rounding it, meaning keeping all the decimal places, although 3 decimal places will be fine, is 36.9035668171 days. We then display 36 days and convert the decimal part into hours, just like the earlier calculation. Now, I'll let you calculate the rest on your own since we've done this before. Then I'll show you the solution afterwards. So pause the video now and give it a go. So, how did it go? Were you able to solve it? Okay, the answer is 36 days, 21 hours, 41 minutes, and 8 seconds before Christmas Day. Now, if you're having problems setting up calculations like this, I encourage you to watch the video that I will be releasing soon about dimensional analysis. A great variety of problems can be solved using this approach. This method makes use of the units of the quantities as a guide in setting up a calculation. And that's exactly what we've done here. We were canceling units, leaving only the units needed for the answer. Alright, let's go back to our JS file and implement these calculations. Okay, first, let's organize our code. Let's create a function called countdown timer. And then cut and paste this section here, followed by this section. And then let's invoke this function. Now, before we do the calculation, I want you to note that my system clock here is quite different from the last time we obtained the value of deltaT and did some calculation to it. I think that was 12 days ago, November 18th, but I still use this calculation as a reference. So, having found deltaT, we will calculate days, hours, minutes, and seconds. Now, let's calculate the number of days. So, let's define a constant, call it daysCalc for calculation, which is this portion here. So, that will be deltaT divided by the whole thing here, 1000 times 60 times 60 times 24. Remember, the answer to this contains both whole number and decimal number, and remember, we want to display the whole number part only. So, how do we do this in JavaScript? Right, using the math object to access the floor function. Math.floor of a number will give us the whole number portion of that number. So, let's define a constant called days and set it equal to math.floor and then pass in days calculation. We can now display the value of days by deleting this content here for the days section and replacing it with the constant days. And there you go. We have 24 days left till Christmas. Let's verify it against my system clock. As you see here, today is November 30th, and it's 25 days before Christmas time, disregarding hours, minutes, and seconds left. So that checks out. Next, let's calculate the remaining hours. This part here. Let's define a constant and call it hours calculation, and set it equal to days calculation minus days. This will give us the decimal portion of this days calculation, and then we multiply it by 24. Again, the result of this will give us both whole number and decimal number. So what do we do next? Right, math.floor. So define a constant and call it hours, and set it equal to math.floor of hours calculation. And then we display the whole number by deleting this section and replacing it with the hours constant. Now, we have 8 hours left until tomorrow. Let's verify it. Right now, it's 3:12 p.m. and if you add 8 hours, that will be 11:12 p.m. And that's correct, since we still have the remaining minutes and seconds to consider. Can you do the minutes and seconds sections by yourself? Okay, pause the video now and give it a go. Alright, how did you do? And here's my solution. I define a constant called minutes calculation and set it equal to hours calculation minus hours to get the decimal part, and then multiplied it by 60. And then to get the whole number part, I use math.floor as usual with minutes calculation as the argument. And then I displayed the value of the constant minutes. Finally, for the seconds calculation, I define a constant seconds calculation and set it equal to minutes calculation minus minutes and multiplied it by 60. And then I use math.floor to get the whole number part and assign it to a constant called seconds. And then finally, I displayed the value of this constant. Now, if you look at the output, it seems like we have a frozen timer. It's not counting down. Does it mean there's something wrong with our code? No, our code works just fine. If we continually refresh our browser, we see that the display is counting down. Let's check our code and see what's happening, and let's think of what are the things that need to be changed in order to make it dynamic. If we scroll up to the part where we invoke the countdown timer function, right here, we only call it once, and that's what we are getting. We are calculating and displaying one instance of time only. What we need is call this function every second rather than calling it only once. But how do we go about it using JavaScript? Well, it's easier than you'd think. Okay, here's the idea. Here's our countdown timer function, and here's another function that will repeatedly call our function with a fixed time delay between each call. And for this project, the time delay is 1 second or 1000 milliseconds. And the good news is we don't have to create this function since JavaScript has a built-in method exactly like this. And this method is the JavaScript setInterval. Okay, let's implement this idea. Let's define a constant and call it timer loop and set it equal to setInterval. And then we input the name of the function that we want to invoke. So it's this function here. And also the time delay in milliseconds, so it's 1000 milliseconds. Alright, now we have a countdown timer that is dynamic. It's counting down. And that's what we want. But this timer will run indefinitely. So how do we stop this timer? And when do we stop it? Okay, currently, here's what our program is doing. Our function is being called by this method over and over again. It's trapped in this loop. We need some sort of stopper to exit this loop. And that stopper is an if condition that always checks, is it Christmas time yet? Is it Christmas time yet? Over and over again. So how do we know that it's Christmas time already? Well, that will be when the current time is equal to the future time, or when deltaT is equal to 0. So once we met that condition, our function calls the clearInterval method, and what it does is it clears the timer that was set with the setInterval method. Then our function triggers the event that we set and then exits the loop. However, do you see any potential problem if we use this condition in our code when delta t is equal to 0 as a stopper? This condition will work if we call our function fast enough so that tc doesn't miss the value of tf. Since tc has to match the value of tf so that delta t is 0, right? But this is not the way we set up the setInterval method. We set it up so that it will call our function every second or every 1000 milliseconds. So that means we are reading the value of tc every 1 second only. So there's a big chance for tc to miss the value of tf, like here. Our timer will continue to count as delta t becomes more and more negative. So that means the condition when delta t is 0 is not a good way to stop our timer. So what will be a better condition to apply here? Right, when delta t is less than 0 rather than when delta t is equal to 0. So let's just do that. Let's add our stopper here. If delta t is less than 0, then exit this loop using the clearInterval method. And then input which loop we want to stop. And we want to stop this loop here, which we define as timer loop. So copy and then paste it here. Now let's create our events. Let's change the inner HTML value of this div here with a class name of timer and with a constant name that we called timer as well. So timer.innerHTML equals h1 element with a content of Merry Christmas. So to be able to check this condition, let's set the future time so that it expired already. You can change any of the inputs here and note that this is a 24-hour clock or it is based on military time. But I'll just change this year's section here from 2021 to year 202. And that will do it. And there you go, we triggered the event. We displayed our message. But how about this one here? We want to display a Fontawesome icon instead of Christmas countdown. Now, this part here is our h1 element and it has a selector of timer-container h1. So we need to bring this to our JS file so that we can tap into it and change its content. Let's copy the selector and then go back to timer.js and define a constant called title and set it equal to document.querySelector and then paste the selector here. Now let's create this event. So title.innerHTML equals the I element. Now, as a review, how do you display this Fontawesome icon having a name of Holly-Berry? It's a solid icon, and the font size is 3 times the current font size setting of our page. So, pause the video and give it a go. How did you do? By now, you're an expert in displaying any Fontawesome icons, which is, I think, an important topic to get familiar with, since it will help you speed up your development. That's why I took the time to go over it. And here's how you display it. We now have a Fontawesome icon and the message Merry Christmas displayed in our page. Now let's go back to year 2021 and verify that our timer is still counting down. And yes, indeed, it still works. Let's bring it back to year 202. Now, the one thing that is missing in our event is the blinking or flashing part. So how do we go about it? So here's how we're going to go about the animation. And coming from an electrical engineering background, this is how I'm going to present this topic to you. So here's our animation. This icon and this text are flashing or blinking or turning on and off every second, non-stop. Now, to be able to analyze this behavior, let's create a timing diagram with a time scale of second. And for the vertical axis, it's usually voltage, But in this case, we set it to color, okay? And we set the 0 index at this position. Now, let's create an object to animate. This exclamation mark here, and then assign two colors. White when this object is visible or on, and then transparent when it's invisible or off. First, let's analyze the behavior of our animation for a span of 1 second, and then let's analyze it for an infinite amount of time. Alright, let's make our object white from 0 to 0.5 seconds, so it's visible. Then from 0.5 seconds to 1 second, let's set it to transparent, so it's invisible. Now, we can represent these numbers right here in terms of percentages. 0% for 0 second, 50% for 0.5 seconds, and then 100% for 1 second. So we say that 50% of the time our animation color is white, and then 50% of the time our animation color is transparent. And also, we say that from 0 to 100% is 1 cycle, and its period, designated by a capital letter T, is 1 second per cycle. And also, if you take the inverse of the period, then we get the frequency, designated by the letter F, with a unit of hertz, and in this case, it's 1 hertz, or 1 cycle per second. Now, this diagram here is showing you 1 cycle only. What if we repeat this 1 cycle here over and over again, non-stop, or infinitely? Okay, let's do that. Let's start from time 0, so it's white for half a second, then it's transparent for another half a second, then it's white again for another half a second, and then transparent, white, transparent, white, and so on. You get the idea. So we have a flashing animation with a period of 1 second running an infinite amount of time. Now, what we have here is a square wave function where the transition from white to transparent or vice versa is abrupt or sudden. So how can we make the transition smooth, such as making the transition from transparent to white or white to transparent gradually? Well, if we make the transition from transparent to white linear with a positive slope like this and a negative slope from white to transparent, then we have smooth transitions. Now, if we let this cycle for an infinite amount of time, and note that I've slowed down the animation here so that we can see the transition better, then we have a flashing animation with a smooth transition from white to transparent, and then transparent to white. Now we have all these diagrams and frequency and period and cycle, but how do we implement all these in CSS? We should be able to tell CSS what will happen at these keyframes at 0%, 50%, and 100%. And we should be able to tell CSS how long should it take to complete a 1 cycle of animation and let it run for an infinite amount of time. Again, it's easier than you think. So let's head back to our CSS file. Okay, so I've added this diagram here for reference. Now, let's go to timer.css and scroll down until you reach the animation section, which is this part here. Alright, as I've mentioned earlier, we need to tell CSS what will happen at these keyframes for one complete cycle. And CSS has a keyword called @keyframes, followed by an animation name, which we call text-animation. You can call it any name that you like, and we will need this name later on. And inside it is a set of rules for the intermediate steps or sequence of an animation. And for our animation, that set of rule is this. Looks familiar? It should. This is just the CSS equivalent of this diagram here for one cycle that we just talked about. So from 0% to 100%, our element color is white, just like here. And from 50% to 100%, the color is transparent as depicted right here. And finally, it goes back to white at 100%. Now, remember this set of rules applies for one cycle only. It doesn't tell you how long a complete cycle should last. It doesn't tell you how the animation progresses through the duration of each cycle. In our case, it's linear. And it doesn't tell you if you want to repeat the animation. And the way we deal with this in CSS is we have to tap into the CSS animation properties like this. First, we want to display the animation name, which is the name of the keyframe we want to tap into. So it's text-animation. And then we specify the animation duration for one cycle, which is 1 second. Then we define the animation timing function, and in our case, it's linear. And then finally, we want to play the animation over and over again, infinite. And then we wrap these animation properties inside a selector that we call flash. Now, we have completely defined the animation through CSS, and yet, if you look at the output, nothing is happening. Why? Well, it's because we have yet to assign the animation to these two elements here. So let's copy this selector and go to timer.js and go to the section where we are displaying these elements. So it's right here. And then let's apply the selector here using the attribute class and then adding it here. Now, we have a complete animation. And not only that, we are finally done with this timer project. Now, if you want to take a look at the completed code that I've written in this tutorial, I'll slowly scroll down each file so that you can see them and compare your code to my code in case you missed something. So here's the HTML file. Here's the CSS file. And here's the JavaScript file. Now, one last thing. This calculation here is typically done with the remainder operator or the modulo operator. It will give you fewer lines of code. And the reason I went to this route is I want you to have practice in setting up your calculations because this is a very important skill to have, not just in programming, but other areas as well, such as engineering, physics, chemistry, and other subjects, especially if you are a student. And here's the equivalent calculation using the modulo operator, and it will run just the same. I'm just gonna leave it to you how it works since you already have the knowledge to deal with this. Just remember, always refer to documentations. Nowadays, everything is just a quick Google away. Alright, well done for finishing this project, and well done for tackling those challenges. If you found this video helpful, check out this website for more tutorials about programming and electrical engineering. So for eftechlab.com, I'm Edgardo Felix.